Hey guys, so this is Dishank, and today I decided to talk about clean architecture in Flutter apps. So, in general, what is clean architecture and why we want to do it in Flutter apps, right? So, clean architecture is a concept where we try to decouple our code base in a way. We are making small module out of it, and we are segregating the responsibilities of all the module so that we don't clutter our code bases, and we are making sure all the small components are only focused on one thing, and hence making the code testable and maintainable so that any new person joins, they know this model is based on this functionality and they have to work on that only, and test cases ensures that they doesn't break the new functionality they are adding on, and existing functionality doesn't also breaks. So that is the idea behind why we are following a clean architecture, and it works like a standard where everyone knows about clean architecture, so once they onboard to a new project, they also not feel alien to that project, and they are also able to contribute effectively in that project. So given that, let's talk about let's talk more about clean architecture. Uh, so I will show you an image which very clearly describes what is clean architecture. So in this image, this is the whole idea about the clean architecture and how the responsibility will flow from up and down and all that. So in this presentation, what is the key thing which I can tell you from the beginning is the entities, because whenever we are getting the data from the backend, we are transforming it into our entities, and whenever we want to show any UI onto our apps, Flutter apps, we get the data from the entities, right? So whenever we are starting on a project, what I have been doing, I will first focus on the entities part. Like I will first go through all the screens I have to be built. I will identify what are the data points I need, and based on those this data point, I create one or multiple entities out of it. Based on the entities I have created, then I will start uh, creating the UI. If the backend is ready already, already ready, then I will get the backend APIs and see what data is coming in which API, in REST API. So now let's talk about this image. So as you can see from the top, there is widgets, which is like a UI presentation layer, and then we have on the bottom presentation or logic holders, which is like the controllers or view models, whatever you can say, based on the architecture you have been following. So in the widgets, we are creating our UI layer, and in the logic holders, so there here we are triggering the actions performed by the user on the widgets, and those logic we are handling in the logic holders, and then we have use cases. That is where the entities are heavily involved. So in the use cases, let's say we have something called user details, right? In the user details, we want to fetch that information, so we have a like user details, fetch user details use case. And when we are fetching that use case, when we get the response back, then we have our user model, user entity, and using that we pass on the data to our presentation logic holders, which is like up of the string, right? Now use cases gets the data from the entities, right? But how the use case is processing its data, that logic of either it wants to call it from the network or from the local storage or from Bluetooth layer, whatever the case is, wherever the data source is, it is being handled at the repository level where we are calling that logic. That's why you can see on the right side there is a call flow. Like the call flow is going from top to bottom, and the response of the call flow will grow from bottom to up, right? So in the repository level, we have that is our data layer. Now the data layer starts. So in that we have our you can see the green blocks is models. So what that models means, key the entities which we want in our UI, so those entities needs to be converted from models, and models contains the logic of serialization and deserialization things. And now if we are calling it from the API, then there is a slight difference in the deserialization logic, and in the local storage there will be some different because we use SQL and all that, right? So that is where the two different models you are seeing under different arrows. Now in the remote data sources, then we are calling the raw data. It can be either in JSON, it can be either in XML or CSV, based on the database. The data has been sent by the server. And in the local storage, it's in our control how do you want to save. It's good practice to store it in the SQL format, the way you are getting it from the API, but you can store it in any different kind of way you want. Now this has now if you have any doubts, do let me know, but I think I have pretty much explained it in a very simple format as I can. This comes with practice and with the experience. So if you are finding it difficult to understand, please read it thoroughly in the articles and on, or just Google it, and keep learning on these things and keep practicing it in your daily work life. Now this has been clear. Now I can show you a code. uh, in this code base, uh, so let's talk about the widget layer. So this is our home screen, right? In the home screen you can view, you can look it. uh, Here this is our UI logic, and here we are calling home view model. Home view model is basically our logic controllers, where we are triggering or getting the data from, right? So let's say we have a text field, and whenever someone writes something on the text field, we are checking if it is not empty. If it is empty, then we are resetting it, and then if there is some data, then we are calling our logic handler, our UI logic handler. In that logic handler, we are going to fetch data from the wiki. So let me go to view model of this page, that is this one. In the view model, we are controlling all the data manipulation by the user in this file. So in this file, the user is going to fetch wiki, and he is querying some words. Now whenever they start typing, and we are just checking some logic, do we find any error? If the query is empty, then we have to clear the wikis, the list of result which the query is sending us basically. And then this is the logic for doing all that calculations. And here you can see, this is the use case. We are going to search query based on the word the user is typing. So now we are going to use this to trigger the query, and we have like dependency injected this particular module. It's not like we are declaring it inside, or we are initializing it inside. We are dependency injecting it. Why? Because if we don't do this approach, then it will be very difficult for us to start unit test this particular module, uh, because we can mock the use case that when we are doing unit testing. And because mocking means, like right now this is a trigger function, and how can I mock it? I can use a mock function, and in that mock function I can just type, whenever someone queries, just send a success response or failure response. So this is a topic which it will be very difficult to understand right off the bat. But if you keep learning on this or googling it, you will get to understand a little day after another, day by day. So this is approach is very commonly used, and this is the most used approach in your all code bases to dependency inject modules. So we have dependency injected use case. Now let's check the logic of this use case. So this is the logic. In the use case, we are uh, calling another repository which is also being dependency injected, because we don't want to clutter our use case logic with the repo logic, because repo logic in itself is very huge, right? So we want to segregate this responsibility in a different module. So that's why this approach is used, dependency injected module approach. So the use case approach is that if we are getting some query, fetch the data. If there is failure, then send back the error. If there is success response, then send the success response back. So that is the only logic being handled here. Is there is data or not? Is there is a failure, or is there is a success? These three things are handled here. All the other things are being handled by the repository. How to actually get the data from the database, or from the API, REST API, and other data sources we can have for this particular query thing. So now you can see, we are calling this function wikidata repo dot request. Here we are sending the query and the pagination page ID. So right now, if we are on the first page, then I will be sending one, and if we are on the 10th page, then we will be sending the 10th plus one. Why the plus one? Because we already have the data of the 10th page, and now we want to get the data of the 11th page, which we don't have. So that's why it will be auto incremented whenever the user is scrolling. So now let's check out this wiki data repo code. So here also we are going to verify by asserting some logics. Do we have the data in the params we are getting from the use case? Then we are checking all the all the values are correct or not. If they are negative, then it means it is wrong, right? So that's why this has been added. And now we are calling the now we are handling the data here by just checking by checking the API, because right now I haven't implemented the database thing, so I have only implemented the API. So here we are getting the data from the API, and then we are checking uh, then we are just convert then we are deserializing the data coming from the API in the dart format. And that is the logic which is written here. And then there are some try catch exceptions. If we have any API level exception, then throw the failure. If we don't know the reason of the failure, then just throw the general exception. That is what has been written here. And then this is the API repository. This is the API data source. So we have the logic is written in this, the API query data, and whatever the parameter it requires, that has been written here. So in the broader sense, if you see the way the code is written, we have modularized all the responsibilities in their own respective files, in their own respective classes, so that API things or API params are all handled in this particular class. The all the repository logic has been written in this particular class. And same goes for the use case and view model. The only reason we do this way, to keep the readability high and the maintainability high. Oh, sorry, the maintainability low. What do you mean by that? We don't have to spend a lot of time trying to understand the 100, 500 lines of code. If we can just break it down into 50 lines of code, that will be much easier to read. Just imagine if I have written all the logic in this view model code, it will be very hard to understand if a new person joins on this project, right? So it will be very difficult. Now, if I can get back to that image, you can see what I just explained. In the UI logic, we have the UI screen logic written. In the view model, we have this presentation layer. Layer is calling the use case. Use case is calling the repository, and the repository is calling its API layer data, database layer data. And that is how the code is written. And that's why everyone focuses on why to use clean architecture. Uh, I hope this has been helpful, and I will definitely share more resources with you guys, or I can attach it down below, and you can find those resources and read it by yourself. One of the article I can share with you is this one, which is very beautifully written. And I hope you have no more doubts on this. If you have, you can reach out to me, and I will happy to help you to clear some of your doubts. uh, this has been a really long video. I hope you get some value out of it, and thank you for watching. And yeah, bye guys.